I thought maybe it's a good idea to record it. So this event is brought to you by Data Talks, which is a Slack community of people who like to talk about data. We have regular weekly events. So this is one of these events that we have on Tuesday, which is a technical event. And today we'll talk about serverless machine learning. And next week we'll talk about a new service from AWS called AWS Glue Data Brew. We also have events on Friday, which are more like live podcast events without slides, where we talk about different topics. And this week we'll talk about standing out as a data scientist in the recruiting process. And then the next week we'll talk about mentoring. Today, Sejal will talk about serverless machine learning with AWS. And Sejal is an experienced data engineer with more than 10 years of experience in software development, and she's proficient in data platforms, infrastructure, cloud architecture, and she will show us today how to deploy machine learning models with AWS Lambda. For questions, we will use Slido today. I will share a link now in Zoom chat. And Sejal, please start. The floor is yours.
Thanks, Alexei. I'll just share my screen. Are you all able to see?
Yes.
Just give me 1 minute, please. Okay, so hope you're all doing well. So yeah, this workshop is basically to give you a context of what really happens when a data scientist approaches a data engineer or machine learning engineer to deploy the model. So this is focused more on the deployment side of a machine learning model. Now, what really happens is in practical machine learning projects, the time spent in actually building the models is much less as compared with the data requirement setup, the data processing and feature engineering phases. So the final step, which is deploying the model into production system, often comes as a collaboration between the data scientists and data engineers. And it is therefore very important to develop DevOps and MLOps skills, which makes collaboration easy and productive. And such skills include, among many, like version control, infrastructure as a core technologies like Docker and Kubernetes. So what you see here basically is what we'll be covering in the workshop. And this is how the workflow is designed. So we'll be training a model inside a container, packaging the service with an image, serving the model with the serverless API, testing locally, and the CI/CD workflow. And the technologies that are used here are Docker plus ECR, container registry, the AWS Lambda for serving API, SAM, which is a serverless framework, which is optional. In case you don't want to use it, you can run Docker commands directly, and GitHub Actions for CI/CD. I like to think these are a good set of technologies if you prefer the infrastructure as a code style to set up in AWS console. This makes things more maintainable and reproducible, also allows storing versions in GitHub, right? So yeah, so now I will begin. So yeah, are you able to see this page on the AWS Lambda support?
Mm-hmm. Yes.
Right. Okay. So the recent updates in AWS Lambda is it now supports up to 10 GB of memory and 6 vCPU cores for Lambda functions. So in a nutshell, these features are they have provided us containers for packaging, which is container tooling for your developer workflows. which means you can package and deploy Lambda functions as container images, Docker, OCI, up to 10 GB in size, and push those images to AWS ECR. Earlier, Lambda only had a provision for zip archives, and later they introduced Lambda layers for packaging dependencies. But in my experience, I had to develop and use a lot of custom workflows for testing, packaging, and deploying. And with ECR integration, it becomes much smoother. It became much smoother for me. And the other feature that I already mentioned as is images. So it is also providing base images, which I will show you for supported Lambda runtimes, such as Python, Java, etc. And alternatively, you can also use extendable base images for custom runtimes based on Amazon Linux to include runtime implementing the Lambda runtime API. So yeah, and for computation, as I mentioned, it's also providing 6 vCPU cores, so which means they have increased the CPU power proportional to the memory increase. And this makes it really easy to build and deploy compute-intensive workloads that rely on sizable dependencies such as use cases in machine learning or high-performance computing to perform faster, right? So there are many more updates that have appeared from AWS reInvent. You can check out their page. So yeah, I will continue with the demonstration part now. So the project structure looks something like this. What we are doing here is we are using the SAM CLI for producing our framework to the machine learning application, and Docker for our image container, and the language of choice. Particularly, I picked Python 3.8. There's also a Python 3.9 version, but the latest support for SAM is Python 3.8. I will start with how this really looks like when you create. So once you have all your prerequisites installed, which is all of these things mentioned here, you can use a SAM CLI to create your project. So I'm going to start with using a quick start template. They have already integrated the image packaging integration into the SAM CLI, so I'm going to start using that. I will pick the 3.8 base, and let's keep a default project name or whatever you like to use. Let's say hello world. We wait for a few minutes and it's created. Sorry, let me just run this from outside because I did not know I was inside the project directory. So, right, okay. So now if I go inside this directory, you will see all the particular files created for this. Let me show you how it looks on PyCharm. So, so as you can see here, SAM basically acts as a wrapper to your CloudFormation template and already generates the file structure as well as the required files to make this entire application functionable. So the first file that is of importance is template.yaml, which contains the configuration to your Lambda function. And also the important part to note here is the metadata part, which points to your image or the Docker file within. And these are basically the important parts. And there's also the package type image mentioned here. If you had not chosen image, it would have been zip or something else. So if we move on to the service directory, which is hello world, which is what is the name we gave to our application, you will notice there is app.py, which is basically our Lambda handler. There is a Docker file created, which pulls this image support that I was speaking about, which is provided by AWS directly, is pulled here. So in our choice of technology, it is Python 3.8, and it copies the requirements, runs the requirements, and basically makes this as an entry point to your Docker file. And requirements, as you already know, this is basically for packaging whichever dependencies you need. And apart from this, there is also a setup created for unit testing to test your Lambda with PyTest. So basically, SAM, I'm using SAM because it has really made it easy for me to create this project structure where I can just start adding my code, right? Let's try to deploy this. So in order to deploy this, I am build. Right. So in a standard Docker-like fashion, you will see the logs here of what it is actually doing. It's basically running the Docker file and configuring the entire application to it. And now we will. So when you try to deploy this to AWS, it will ask you what you want to name your stack. Fill accordingly. I'm going to use uCentral1. The image repository. So as mentioned in one prerequisite that you also need is to have your ECR repository created. I'm going to use an existing one. My ECR exists here. So I will try to use this particular repository. Copy this. Here. Confirm changes. Allow CLI to create an IAM role for me. Okay. Save arguments to configuration file. Yes. Okay, that's nice. So let's look here. So what is happening here is there's already, like before this workshop, I already tried an example, and it has already detected a stack with the same name and the same application code. So it is not making any changes yet. I will try to run the same here. If you go to your service, excuse me. Right. So this is basically how the Docker integration with the new Lambda update is like. Sorry, do you have a question? Hello? Okay, I'll continue. So you saw how we could use SAM to generate our project structure and make use of new feature provided by AWS, that is integrating a Docker image, or particularly any image, into our Lambda application, right? So let's move to the main one, which is this ML workshop. What I've basically done here is by using the same structure provided by Sam, I have extended it by adding a train.py file for my training script. And this is a basic logistic regression model. Let's not focus on the accuracy of the model, because this workshop is more focused on the deployment. But basically, this is using a scikit-learn data set and splitting it into training and test samples, and serializing the model with Pickle and generating the file. Now, what I've particularly used here is a multi-stage build in Docker, which means it will run the training script inside the Docker container and tightly couple the serialized model with the service. I have chosen this approach because we are currently having a small scale application, and it makes sense to have a monorepo style where you can integrate the model as well as the application code within the same container, and so that your service can directly make use of it from here by just providing the model path. You can directly just pull it from the ECR. The alternative approach, which is generally used in production workloads, is you can deploy the model in an independent pipeline to an S3 bucket, and have your service use Bodo3 or any SDK to download this model from S3 and then use it in the service. So this is also a good workflow if you want to keep the deployment, basically the CI/CD actions, separate in case your model is not changing rapidly, or let's say in case your application code is not changing as rapidly, then you can do this. But I particularly like the ECR approach for versioning of models, which you can also see here. So, and then the latest one would be tagged to the latest tag here and just make use of the code. So it's really up to you how you want to do it. Let's go back to this. Right. So now I will try running again. Use the defaults. One thing of importance is SAM also creates a terminal file here with all the configuration that you passed at runtime into this, which is important for it to package, which is the CloudFormation stack name, the S3 prefix, image repository, region, etc. Right? And let's see. Right, it is now deployed. We can look it up first. Okay, either way. Okay, let's check. I haven't really made any code changes yet. So, right, let's try to run this. It works successfully. That's really nice. Okay, so yeah, this was basically the model deployment part. Now let's say if you want to test this locally before deployment, you can make use of the local testing API provided by this framework, which redirects you to localhost on that 3000 port. So from here, I'm just going to make a post API. and you get your output. Alternatively, if you do not wish to use a SAM framework, you can reproduce this framework using Docker itself. So you can run something like
Sorry, we can't hear you.
can you hear me now?
So it comes and goes. It happened like 3 times so far, but now it's the longest.
Okay. Are you able to hear me now? Sorry.
Yes, now it's back again. Thank you.
Yeah, thank you. Okay, so with the Docker way of things, like once I ran the Docker container, I'm pointing to port 8080. I made a call to the service itself, and this produces the same output as what we saw in the lambda function online. So this is basically how you can have the local testing done with Docker as well as with the SAM framework, right? And yeah, so basically I have provided, I'll share this repository with you, and you can you can try this example out by yourself and see if it works. And yeah, the next section is the CI/CD workflow using GitHub Actions. So what I've done here is firstly, you need to configure your secrets for AWS, which is your AWS key ID and secret ID. And then you can use one of the existing workflows provided by GitHub, or you can write your own. So let's say you go to new workflow, and I choose the Python application. And for my I've used a Python application workflow for my unit tests and linting and things like that. For the deployment, I've written a custom one, which I will show in some time. So this is how it would look like if you're making use of the CI framework. One second. Right. So I haven't really made any changes to the existing Python GitHub Action workflow. They are already providing the rules for installing your requirements, linting with a library called Flake8, and this, and also the PyTest part. I have just added these 2 lines additionally because I also want to see a coverage report. And when the important part here to note is I am pointing to the dev branch here. So every time there is a push to the dev branch, this action will be activated, and it will check all the unit tests and linting, code linting, and stuff like that. So this is basically how the output will look like. This is the coverage report for my application. And it shows that one I only had one test basically in my container. I basically had only one test for my Lambda handler. And my test handler also has PyTest fixtures, which is to mock certain variables or values that you want to pass within your code. For example, Boto3 is not a native Python provision, so you can mock a Boto3 event, for example. In this case, it's an API gateway event to construct this so that you can pass it into your function so that it mimics that environment. And I have also marked the environment variable to be used within Lambda. Right. And for the deployment part, for the deployment part, it's a regular bash script. So I am installing the AWS CLI requirements here and setting my environment variables. This is picking up the access keys, access and secret key pair from the secrets, which we set from here. And just running the SAM build and the SAM deploy command. This is how a SAM deployment would also look like. And this will basically push it directly to the ECR repository that you have provided. So basically the point of this workflow is when you create a pull request, you push it to a feature branch, and once it's approved and it's merged into the development branch, the dev branch can deploy your application to the staging environment. And similarly, you can have a GitHub action created for the master branch as well to deploy your application to the production environment. So yeah, this basically completes the entire demonstration of this workshop. But yeah, I mean, I'm free to take some questions now, or maybe we can conclude.
I have one question.
Right.
Thank you very much for the presentation. I really enjoyed all the sections. So I have a question about the first section when you were talking about the training inside the Docker. So as far as I know, the Lambda has a timeout of 15 minutes. So, and I also know that training models usually takes longer than 15 minutes. So do we then only, so how does this work in this case? Or should we just work on classical machine learning models, which takes less than 15 minutes, if it's possible?
Right. This is actually a good question. So this also depends upon the new update that has been provided by AWS. So it's conventionally the timeout that has been provided by Lambda is 15 minutes. And conventionally also they have provided a memory of 3 GB with, I think, only 1 or 2 CPU cores. But with the recent update, they have expanded the memory up to 10 GB and also increased the CPU cores to 6, which makes it really faster in performance and therefore reduces the time taken to process. So if you have a machine learning application that is using a conventional style before the update came in, you can try both the ways out and see if there is a performance change, because I definitely noticed it. And But I would also like to highlight that I would use serverless when there are small scale applications, that is when your model is small, because the Lambda reloads your model on each request. So a large model is definitely going to provide slow response time. And also when the data vectors are small, uh, because Lambda has a 10 GB memory ceiling. So if you are having a large serialized model, then it's better to store it in an S3 bucket and load it into Lambda. And your model will also be sporadically accessed. And the advantage I see is actually low cost, because Lambda charges only about 0.2 per million requests. But for heavy production loads, I would still recommend using SageMaker, and you can have a Lambda endpoint to access it. For this, I would also recommend one of the workshops done previously in Data Talks Club by Dimitri, that is deploying machine learning models on SageMaker. So yeah, you can also check that out to see how things work out for you.
Thank you.
Thanks.
We have a couple of questions in Slido. If I
Sure.
can start sharing my screen.
Absolutely.
Yeah, so I just posted a link to Slido in chat. So if you want to ask a question, please use that.
Should I stop sharing my
Yes,
screen?
please. Okay. So the first question we have is, what are the benefits of using Docker compared to the old way of deploying Lambda functions?
When I have used the old way of deploying Lambda functions, I made use of a serverless framework or even a SAM framework, or there are many such frameworks available like Zappa, where you can package your infrastructure and your code directly and deploy it. So this is a very simple use case that I'm talking about right now, which is good for prototyping. But Docker really makes it easier to make use. I mean, Docker images really help to integrate your packaging and code. And because of this new update provided by AWS Lambda, you can directly deploy this Docker image onto your ECR container and make use of it directly. So this is where the main benefit comes in. If you want to use Docker images with deploying Lambda functions in a conventional way, that is before the update came in, you can have a custom workflow designed for it. But it will just take some more additional steps to have this running. Does that answer your question? Okay.
Why do we need SAM? What are the main benefits of using SAM?
So you don't really need SAM. Like I said, you can deploy the same application using Docker as well. And you can write your GitHub workflow or even a shared script to execute all of these Docker commands to build and to deploy your application. I see one advantage of a framework like SAM to generate the project structure. Basically, it's a framework that acts over a cloud formation template, which organizes your files and like automatically generates the configuration information needed for your application and to package it. So you can choose not to use it also, but you will just have to write additional steps to integrate it with CloudFormation and Docker.
And SAM and serverless are different frameworks, or that's the same thing?
Sorry, I didn't get that question.
Yeah, so we also have the serverless framework, or this is the same thing as SAM, right?
There is also an open source framework called Serverless, a serverless framework. Because it's open source and not officially AWS's, it does not yet have the image repository configuration available, which is also why I've used SAM here.
Okay, I, to be honest, actually thought they are the same thing. So SAM is something from AWS, right?
Right. Yeah, and serverless is not.
Okay. Bob asks is there any loading speed difference for large models from S3 versus them being a part of the image in ACR?
I haven't really tested this out yet. I do want to. But one advantage that I really see here is in terms of storage, because the ECR image has up to 10 GB of storage, storage limit. And if you're combining it with your application code, it is quite possible you might max out the limit. In terms of using S3, I think you can keep your pipelines decoupled. That is for separately for storing the S3 model into S3 and your application code differently. Yeah. How will this workflow different from deploying a deep learning model? I didn't entirely get this question.
So the way I understood the question is, so you basically showed how to do it with scikit-learn, but let's say you have a Keras model or a PyTorch model. What would be the different steps in this case if we had a Keras model?
I don't see much of a difference in the workflow, because just the way I am importing scikit-learn libraries, you can import the PyTorch libraries and TensorFlow libraries as well. The difference would probably be in the load and performance, which needs to be tested out. Also, regarding this, there's a really nice workshop that Alexi has prepared, which is available on the Slack channel. It's called Deploying Deep Learning Models with AWS Lambda, right?
Yeah, thanks for mentioning.
No problem. So do check that out. It's particularly focused on deep learning as a use case. And I've used a similar workflow and just automated things with GitHub and Docker in my workshop there.
Thank you for answering.
So yeah, this is basically it. To conclude, basically, I would say as one of the questions that was framed here, is machine learning a good fit for serverless? I would really say, if your model is small and if you want to prototype things, basically if your data and the performance and load is smaller and can fit within 10 GB of memory space, then you can use this. But if you have really large production loads, it makes sense to use something like SageMaker to expand this architecture. You can also make use of a message queue like SQS. You could also try using Lambda layers, although I'm not very sure of how it is because I did not have a good experience with it. But using ECR image and loading the package dependencies from there directly has been a good experience for me. And yeah, that's about it. Any further questions?
I don't see any questions in Slido.
Okay, I really hope you enjoyed this. Thank you. And yeah, I will prepare a companion article if you like, because most of the content was described during the video and not much of content is available on the GitHub repository. Let me just share my GitHub repository as well. Alexi, should I share it on the chat?
Yeah, you can put it in chat and then also in Slack.
Here you go. And like I said, it's just it's a basic framework with the first steps taken. There's definitely scope for improving this further. So if you have any feedback, suggestions, please feel free to shoot. All right, then.
Thank you, Sejal, for presenting, for sharing your knowledge with us.
Thanks,
Thank
Alexi.
you, everyone, for coming.
Yeah.
See you soon.
See you.
Bye.
Thank you. See you.
Thank you.